Let's try to understand the foundations of reaction stoichiometry by taking the example of an egg sandwich. So let's say if you want to make an egg sandwich, you'll need 2 slices of bread. So 1 slice, 2 slices of bread, and you'll need 1 egg. Let's say we made a little omelet out of this egg. Okay, so there's the egg and there is the bread. Okay, so you need 2 breads, so let's call bread B, plus 1 egg, so let's call egg E, and that makes 1 egg sandwich. Now, if you had to make 4 egg sandwiches, then you would need, for 4 egg sandwiches, you would need 4 eggs and 8 slices of bread. Now you can think of this fairly intuitively, right? Now, turns out reactions work in the same way. So let's take a reaction. Let's take carbon plus oxygen makes carbon dioxide. Turns out, to make 1 molecule of carbon dioxide, you need 1 molecule of carbon and then 2 oxygens that are actually combined into 1 molecule. Okay, so that's kind of how it works. Now it gets a little more complicated when you start looking at a fully balanced reaction, but the foundation is still the same. So let's take a little different reaction and look at that. So let's say we have nitrogen plus hydrogen gives me NH3, and that's not balanced, so we got to balance it. That's 2 out there and 3 out there. So we have a balanced reaction. So it turns out what this reaction is really telling us, that if we think in terms of molecules, it's telling us that we need 1 molecule of nitrogen plus 3 molecules of hydrogen, H2, and that gives us 2 molecules of NH3. Okay, so that's how it works. If you think in terms of moles, which is what you'll be using quite a lot, you can do the same thing. We need 1 mole of this species plus 3 moles of this species gives us 2 moles of this species. Okay, now key thing to remember when you're looking at all this, don't worry about the subscripts. Don't worry about these guys. So I'll just take a little red marker and just cross them out. Don't worry about those guys. They're there, but ignore them. Okay, so you're going to ignore them. What you will pay attention to is the coefficient of each of these. And by coefficient, I mean the number sitting out here. Out here, if there's no number, that means it's a 1. Okay, so that's what you will pay attention to. And therefore, when I write molecules, moles, I'm actually looking at the coefficient 1, 3, 2. So you can look at it in terms of molecules, you can look at it in terms of moles, 1, 3, 2, and so on. Okay. Now, turns out you can take these same relationships and convert them into grams. So if you look at this in terms of grams, all you need to understand is to convert moles to grams, you have to multiply each of them with their respective molar mass. So therefore, if you multiply this with the molar mass of nitrogen, on approximately the molar mass of nitrogen is 1 nitrogen is 14.07. Since there are 2 out there, that's 28.14. Multiply that gives me 28.14 grams. That means if we combine 28.14 grams of nitrogen with 3 times hydrogen, so 1 hydrogen is about 1.008. Because there's 2, the molar mass of that is 2.016. And since there are 3 total units, we multiply that with 3, and that should give us, sorry, I have to go get my calculator. That should give us 3 times 2.016, which is equal to 6.048 grams. And this one, that's about 17. So 2 times 17, let's just do it correctly. So let's just add a little more accuracy to this. So nitrogen is 14.007 plus hydrogen, each hydrogen is 1.008, and there are 3 hydrogens. So that gives me a total of 3 times 1.008 plus 14.007, 17.031 grams. That's this, but I have to multiply that with 2. So 2 times that would be equal to 34.062 grams. So basically what I'm saying is that to satisfy this balanced equation out here, 28.14 grams of nitrogen is needed to be combined with 6.048 grams of hydrogen, and that collectively gives us 34.062 grams of ammonia, NH3. Okay. Now let me just double check that, because I think I'm not quite sure I did it, but I did that in my head, so that maybe that I believe that's a little wrong. So 14.007 is nitrogen times 2. That should be 14.007 times 2, which should be 28.014. So that's 28.014 grams. Okay, so that's basically it. Okay, so now when you kind of take a look at this, once you have the balanced equation, your reaction stoichiometry is how do you kind of read the reaction in terms of molecules, moles, or grams. Now let's take a look, let's take a deeper dive into what happens with this information, how you can apply it. So if you look at this reaction, we can say that 1 mole of N2 reacts with 3 moles of H2 to give 2 moles of NH3. Some other things we can figure out from this. We can directly relate the N2 to the NH3 by saying 1 mole of nitrogen forms 2 moles of NH3, or we can say 1 mole of nitrogen reacts with 3 moles of hydrogen. Okay, so there's a few different ways you can look at this. You don't have to always factor in all 3 of them in what you're looking at. So this is very crucial, because once you know that you can relate any 2 to each other, that becomes a conversion factor. What I mean by that is, see the first one out here, that could become a conversion factor 1 mole of N2 over 2 moles of NH3, or it could be 2 moles of NH3 over 1 mole of N2, right? And you can do the same thing with this. This one would become 1 mole N2 over 3 moles of H2, or you could write 3 moles of H2 over 1 mole of N2. Okay. So then the next thing becomes, if I ask you a question, if I gave you 7 moles of N2, how many moles of NH3 would be formed? 7 moles of N2, okay? So I'll use a different color out here. So you have 7 moles of N2, you're trying to figure out how many moles of NH3 would be formed. So then all you got to do is relate the N2 with the NH3 and use the appropriate conversion factor. So 7 moles of N2 If you're trying to figure out NH3, then that is the conversion factor you'll use. So that's multiplied by 2 moles of NH3 over 1 mole of N2. Okay, and as you can see, the moles of N2 cancels out, so 7 times 2, so that I should get 14 moles of NH3. So that's the uniqueness of this method. Let's say we have this reaction out here, and what we're asked to find out, what we ask you to find out is, if I gave you 37 moles of oxygen, which is your O2, how many moles of carbon dioxide are produced? So then I can just relate the oxygen and the carbon dioxide and create a conversion factor from these two. Okay, so watch how I do it. So I start out with 37 moles of oxygen, and the conversion factor, since I'm trying to find carbon dioxide, I put carbon dioxide on top. Since it's 1, I put 1 carbon dioxide, and below I put 2 oxygens. Okay, and then I just simplify that. Turns out in this case, that would be 18.5 moles of carbon dioxide, since that'll cancel out. Okay, I hope that made sense. Now, oftentimes, you can take this a little further too. And what I mean by that is, let's say the question says, how many grams of carbon dioxide are formed? So to find grams, you have to convert the moles of carbon dioxide to grams. For that, you need the molar mass of carbon dioxide. So let's go ahead and compute the molar mass of carbon dioxide. I'm going to call that mm. Carbon is 12.01 and oxygen is about 16. There's 2 oxygens, so there's, multiply that by 2. So that gives me 12.01 plus 32.00, which gives me a total of 44.01 grams per mole. There you go. So that is the molar mass of carbon dioxide. To find the grams, we will just, so grams carbon dioxide, we take the moles times the molar mass, which is 44.01 grams per mole, and that gives me 814.185 grams. Now we can correct that for significant figures. So we're looking at 3 significant figures out here, so that's really 814 grams of carbon dioxide. Okay, so now oftentimes a problem might, notice carefully, in this problem what we did is we started off with moles, we ended up with moles. Okay, and then we said if we want to end up with grams, we could convert the moles to grams using the molar mass. Oftentimes the problem will give you grams and ask you for either moles or grams or something else. So then you just have to kind of take the grams and convert them to moles, and then moles to moles, and then moles to grams. So the roadmap should be like this. Grams to moles to moles to grams. That's your roadmap. Okay. Oftentimes your starting point might be here, which takes you there. Sometimes your ending point could be here, so then you go from here to here, or your starting point could be here. You might need to end here or here. Depending upon which way you want to go, that is your roadmap. And keep in mind, when you go from grams to moles, you divide by the molar mass. When you go from moles to grams, you multiply with the molar mass. Okay? And of course, for this mole to mole conversion, you have to find the conversion factor in the equation itself. So conversion factor from balanced equation. Crucial. Okay, very important. All right. So let's say we have another question where we're given, what we're giving you is 64 grams of CH4 is reacting, and you're asked to figure out how many grams of water is formed. Okay, so we're gonna go straight from here right up to there. Okay, so first step, we got to change the grams of CH4 to moles of CH4. So for that, we need the molar mass of CH4. So let's calculate that out here. Molar mass of CH4, carbon is 12.01, each hydrogen is 1.008 times 4. Let's do that real quick on my calculator. So that's 16.042 grams per mole. Okay, so we divide grams by the molar mass to get moles. So 64.00 grams CH4 divided by 16.042 grams per mole. That gives me 3.9895 moles. Okay, now we have to relate the moles of CH4 to the moles of water, because that's what the question is asking us. So I'm going to use this relationship to create a conversion factor. So it's going to be, so to find out the moles of water, we start with these many moles, 3.9895 moles CH4, and I'm going to multiply it with the conversion factor with water on top. So 2 H2O over 1 CH4. That is going to give me 7.97905 moles water. Now I have to take those moles of water and convert it to grams by multiplying with the molar mass of water. The molar mass of water is 18.02 grams. If I multiply those two together, I get 143.7825 grams of water. Now I'm going to check for significant figures and make sure everything looks right. So we started off with 4 significant figures. We only did division and multiplication, so really we should stop at the 7 out here. That should be rounded up. So 143.8 grams of water is the correct answer.